Hi, this is Staking Nerd Talk 6. I'm Yorick, and with me I have,
Hi, I'm
can you introduce
Patches.
yourself? Hello, Patches. New face on Staking Nerd Talk. Thanks for doing this with us, with
I
the
am
eStaker group.
super happy to be here.
And what happened to Remy?
You tell me. I think I know a little bit, but it's really interesting stuff that he's doing right now and why he can't be here. So,
Yeah, so Remy has decided that he's going to try having a life. He's been involved with a search and rescue group all along. He's going to focus more on that and on nature in general and life, and a lot less on Ethereum. And that also means he's uh, not completely stopping what he does with the eStaker, but dialing it back severely. Um, all the infrastructure work he's doing for us, probably some of the coding work, and definitely this. So really good for him, and it's amazing,
and it's good for me too because it means that I have the opportunity to be here.
right? So the topics we're covering today, we are going to lean into what's coming with Glamsterdam, the next hard fork, and what that means for stakers. Main topic, I think, is going to be ePBS, enshrined proposer builder separation. Briefly, BAL, the access lists, and what that means for performance of a staking node. Um, I'd love to, you had mentioned Patches, that we could touch on zkEVM and proof verification. I think that fits into Glamsterdam as well. Um, we want to talk briefly about the EthStaker stage at EthCC that is coming up in a week and a half, 2 weeks, something like that. And then if we have time, we're going to touch on two EIPs in Glamsterdam that are kind of interesting but aren't headliners.
Sounds great.
So why don't we start with enshrined proposer builder separation? Do you want to give us a high level overview, Patches, of what is changing for stakers there? What do they need to pay attention to? What does this do for them?
Sure. I think it might help if we talk a little bit about the current state of proposer builder separation and MEV boost, which is the implementation of it that most people use. Um, Essentially, back in the day before the merge, when Ethereum was still a proof of work blockchain, building a block could be profitable because you had an opportunity to organize the transactions that you put into that block in a way that led to some sort of opportunities to profit. And back then we called it miner extractable value or mined extractable value or something like that.
Mhm.
That definition has transitioned into maximum extractable value as we've gone away from mining. Um, and the ability to organize those transactions has shifted from being a miner's responsibility to a staker's responsibility in proof of stake. Um, but actually finding those profit opportunities is a very challenging problem. It's very complicated and it's very specialized and it requires some pretty beefy hardware. So proposer builder separation up to this point has been a sort of external service to your validator client. So if you're a home staker, you probably run MEV boost. And when it's your turn to propose a block, you'll essentially have your validator sign what's called a blinded block, where you've asked an MEV relay like Flashbots to give you just the header of a block, which contains a hash of the block body. So you don't actually know what's inside the block. You just sign the header and you give that back to the relay to prove that you've signed it, essentially, which makes it safe for them to reveal the contents of the block because they know that it'll be included when your block is proposed. Um, if you propose a different block and you sort of like don't propose the block that the relay provides you, even though you signed it, you can get slashed. So there's some protection from the relay side that you're not going to essentially decipher what it was that they did to profit. And they share a large portion generally of those profits with the validator.
right?
Okay, so that's the current state of the world.
That's the current state. Couple questions about the current state. So you mentioned MEV Boost. I do have to do a quick shout out as well. The second sidecar that people might use is Commit Boost. Um, how much time does somebody have to re-execute the block once it's been unblinded and then say it's correct and attest to that?
So right now you have 4 seconds. The block is due at the beginning of the slot, and then over the next 4 seconds, you are essentially running the execution payload of the block against your local execution client as an attester, and you're saying whether or not it's valid, and you submit an attestation to the network, and it gets aggregated into the next block if you do it in a timely fashion.
Right. And, briefly mentioned here, we'll get to that later as well. People do play timing games, so you might not actually have the full 4 seconds because you don't see the block right away. Do you know how many blocks are currently being built by the centralized builders and how many are being built locally, roughly?
I actually don't remember, but I understand that a large portion of blocks are published by relays and not directly by beacon clients that are participating in the network. So I think there aren't that many builders, and it's safe to say that like the largest builder probably has double-digit percentage of the blocks that get published.
I think that's right. I have a number in mind of like 90% builder and 10% local. Sounds directionally correct. It might not be the exact number. And that we have something like 3 major builders and then maybe a couple aside from that. So it's fairly centralized from a building perspective, but still very decentralized for attestations. So now how does this change with enshrined proposer builder separation?
So in ePBS, when it's your turn to propose, instead of asking for a blinded block from a relay, you ask for a bid from a builder. And you can ask multiple builders for bids and sort of pick the highest one. And that bid is a signed message from a builder that says that they will publish an execution payload with a certain hash, meaning that like they have already figured out what contents they want, what transactions they want to include, and they'll pay you a certain amount to do it. And in enshrined PBS, when you publish that bid, it's binding. So this works out a little bit better for validators because without the enshrinement, you're always trusting that the builder will honor their side of the agreement to share their profits with you. And now that you're just signing a bid and publishing a bid, you're essentially accepting the bid formally on the beacon chain, and the builder is forced to pay you after you've accepted the bid, even if they fail to publish the block.
Right. There's a nuance there that I'm still struggling with, which is that bids can come through a peer-to-peer network, and I know that is a trustless payment method, but I don't know how that works when you directly connect to a builder via the API, because that's faster, right? You don't have to wait for peer-to-peer, and peer-to-peer is considered a fallback here, a liveness fallback. Whether that's a trusted bid or a trustless bid, you know?
Yeah, I actually meant to do a bit more research into this last night. Unfortunately, I had an internet outage.
It's all good. It's all good. We're all learning as we go, and we'll have the EthCC part later, and I'll mention a couple talks about that at the eStake stage. Okay,
Yeah.
so that's the change where we don't need the relay anymore. So the validator doesn't have to trust the relay, and the builder doesn't have to trust the relay. That seems like a good. That's probably not enough to do this big of a lift because we're changing a lot in the underlying consensus layer protocol. What else is changing?
So the structure of the slot is changing substantially. And part of that is due to the observation that we're not actually using the full 12 seconds in the most optimal way. There's sort of a lot of free time based on when our expectations are set that things will arrive. And so I jotted down the changes, but currently slots are basically split into 3 sections. At the beginning of the slot, the block has been proposed and validators are validating it. A third of the way through the slot, so at the 4-second mark, attestations are being published, and that's basically just each validator saying that this block is valid or not, as the case may be. And then 2/3 of the way through the slot, the aggregation window starts, and that's when the attestations all get combined. It's sort of a form of compression that makes it so that the full set of attestations from all of the validators, which there's over 1 million, I think, can fit inside a single block. That's the current structure. In
And at that point, you'd
ePBS,
also start. So once the block has been published, you'd also start building the next block, right?
yeah, so in the last third of a slot, you can start building the next slot. You do want to include the aggregated attestations, but usually by that point you have the majority of attestations, and so there's not that much to do. So you do have 4 seconds to build the next block. And we can talk a little bit about timing games really quickly, where that 4-second window at the end of the slot is when you're supposed to be building. But because MEV is easier to extract when you have more transactions, it's profitable sometimes to wait a little bit longer to get more transactions into the mempool, or to search through them and try and order them in more profitable ways. So it's possible that you might actually propose the next block instead of at the 0-second mark of the slot, like 1 to 2 seconds into the slot.
Yeah, and we've seen a lot of that, and I know there's some concern that this will cause issues as we ramp up gas limits, and just makes it harder for testers, right? It's really good for proposers and builders, but it makes it very hard for testers to be timely.
Right. The sort of the longer the testers have with the block, the easier it is for them to validate the block within the time that they have. So in order to attest to a block, you need to be certain of its validity, which means that you actually have to re-execute all of the transactions against your local execution client and make sure that the outcome of the block is as described.
Yeah, so that's the current block structure. What does the new block structure look like? A slot structure, I should say. Sorry.
In Glamsterdam, instead of even thirds, there's sort of a handful of checkpoints throughout the slot that are interesting or relevant. The block is still proposed at the 0-second in the slot, but the block no longer contains an execution payload. It just contains that signed bid that we were talking about. And so once that block is proposed, there's a 3-second point instead of a 4-second point where attestations start to be published. But these attestations don't imply that the execution payload is valid. They just imply that the beacon block is valid. At the 6-second point, so halfway through the slot, aggregations begin to happen. And that point is also at which the builder has to reveal the block reveal the execution block that corresponds to the beacon block.
At 4 seconds, I think, yeah, and at 6 seconds, the timeliness has to be in.
Yeah, that's right. At 6 seconds, the timeliness. So there's a new duty that I think there's 512 validators in a given slot who essentially say whether or not the builder revealed the execution payload in a timely fashion. And that's important because when we get to the next slot, you need to say whether each attestation essentially needs to say whether or not the previous slot had an execution payload in it. And if the builder wanted to wait, if we didn't have this timeliness attestation, the builder could essentially wait until close to the end of the slot, and that would create a sort of uncertainty among the validators as to whether or not they actually revealed the execution layer side. So there's timeliness stuff that's due at the 9-second point, I think.
I think timeliness is 6 seconds. And then by
point.
9 seconds, we need to have verified the payload.
Yeah, that sounds right. So at the 9-second point, you have to have verified both the beacon block and the execution block. And that is substantially longer than you have right now. where all of that verification happens in 4 seconds. The beacon payload verification is the bulk of that, though. You have the full 9 seconds for beacon payload verification. Verifying the actual execution payload, you have less because it was revealed later in the slot.
Right. Okay,
then,
so we're decoupling the beacon block from the execution payload. I think there's two ways we can go here now in this discussion. One is, okay, why are we doing that extra complexity? Or the second one might be, maybe we take that first. Well, what does that mean for validators, home validators in particular? How does that change their bandwidth requirement, their resource requirements more generally? How does that change the configuration?
So when home validators have multiple different roles, and I think as an attester, your bandwidth requirements don't really change that much. And that's because when you receive the beacon block, you're just getting a small portion of the previous bandwidth requirement, but you get the rest of it later when you have to also receive the execution payload.
Right.
As a proposer, it depends on whether you've been using MEV boost or not. If you're building blocks naively, your bandwidth requirements have gone up since the BPO fork started, since Fusaka, right? So now you have to publish all these blobs. The difference is that if you're building a block locally in Glamsterdam, you still have to publish those blobs, but you publish them at a later point in the slot. So I think I'm not sure if you have more time to do it, honestly, because of the attestation window is so much longer. But the sort of upload bandwidth that's required is spread out across the slot instead of all at once.
Yeah, that's my understanding from what I remember from POTUS, that you do have more time to get this in.
Yeah, and I think because the attestation window is so much longer, it would make sense that you actually have a lower bandwidth requirement to publish the execution payload. If you're using MEV boost, you never had to do that in the first place. I think you just signed the block header and you publish that.
Right.
And then the relay itself can publish the full block to the peer-to-peer network, but I'm pretty sure that most clients download it and publish it anyway. So your bandwidth requirements are still fairly high.
With a slight wrinkle here that several validator clients default to a builder boost or proposer boost of 10%. So unless the remote builder pays 10% more than local, they'll build local.
Yeah. And being able to build local is good for a lot of reasons. I think one of the main ones is censorship resistance, because in PBS, the builder set is so centralized, they could be coerced to exclude certain transactions from blocks. And we then rely on people who build blocks locally to include those blocks include those transactions in their blocks since they get naively ordered into the block. And I think we'll touch on FOCIL at some point probably, but that is one of the things that will mitigate that centralization concern.
Yeah. So we have a bit more time to re-execute the block. Am I right in thinking that that removes CPU pressure from home stakers when they're re-executing? They have a bit more time and they can more easily absorb gas limit increases.
Yeah, and I think you get 9 seconds now, and that's because the payload was revealed halfway through the first slot, and you don't have to publish an attestation in the next slot until the 3-second mark in the subsequent slot. So that's 6 seconds in the current slot plus 3 seconds in the next slot.
Okay. I'm still completely unclear about this, by the way. I know we've been discussing this, and I was just going to say to anyone watching this, it's okay. I certainly don't feel like I need to fully understand this yet. We'll get there. So my understanding differs from yours, Patches. We had discussed that. I think I think 4 seconds for reveal, 6 seconds for timeliness, 9 seconds to say I've verified it. Here's my attestation to the payload, and then the next 3 seconds we start on the new slot. So we're already again at 0 seconds. But whatever it is, whether I have 5 seconds to verify this or 9 seconds to verify it, we get more time.
Yeah, and that means that you can potentially run with the current gas limit, you potentially run a validator on a less powerful machine. But ultimately, the goal is not to reduce the hardware requirements, it's to increase the gas limit.
Exactly. Although we'll likely get to both. So maybe this is time to briefly touch on the other headliner, access lists.
Yeah, these are really cool. Right now, essentially, when you are reprocessing a block, you go through it transaction by transaction, and you run each transaction in the EVM, in your execution client, one at a time. And computers are
So in
built to do
practical
more than one thing
terms,
at a time.
if I have a 16-core Threadripper or whatever, I'm using one core.
You're using probably more than one core, just not for this particular workflow. So this particular workflow is a sequential workflow. It's not parallelizable as it is today. And
With
the
short caveat there, because I know they'll say it, Beso is already doing some optimistic parallelization even before BAL, so it's sort of parallelizable, but not really well.
Yeah, I think a lot of the times in software, we talk about the worst case runtime. And the worst case runtime for a block right now is that it has to be executed fully in sequence because each transaction that you include changes the input to the subsequent transaction in the block. And it might be possible to do some sort of optimistic parallelization that would mirror, if you're really a computer nerd, that would mirror something like pipelining in the CPU, where you optimistically start executing the next command in the program before you finish executing the one you're currently executing. And occasionally you actually have to drop your pipeline and then re-execute
Restart
the first one. Yeah. And that's a really cool optimization. But we can do better because we want the worst case runtime to be predictable, essentially. And that helps us optimize things and speed things up, increase the gas limit. So the proposal for BALs, which are block level access lists, is essentially that when a block is published, it comes with a sort of digest of what addresses will be modified by all of the transactions. And you can use that to figure out which transactions are mutually exclusive and which ones can be parallelized.
Right. So let's say that, there's a transaction that has your download ETH and one that has patches.eth, then those two could be done in parallel. They have nothing to do with each other.
Yeah, and I think the thing that's important to understand about that is that it doesn't actually matter what order those two transactions are executed in. You can execute either one before the other, and the final state remains the same. If I send ETH to person A and you send ETH to person B, no matter which one of those things happens first, person A gets the ETH from me and person B gets the ETH from you. They would be mutually exclusive if I sent ETH to person A and then person A sent ETH to you, because now there's a dependency chain, right? So the transaction that I execute has to happen first to increase the balance of person A. Person A then has the ETH to send to you, which they may not have had before.
Right. Or if I send something to A and you send something to A, and then A does the swap, right? That needs to happen in sequence.
Yes. And a block level access list is a sort of elegant solution that doesn't change the fundamental structure of the block. It just adds a little bit of extra information that tells you that certain transactions can be executed in parallel. So now when you're processing the block, instead of having to do everything in series, or sort of the worst case is that you have to do everything in series, the worst case becomes well defined by the number of transactions in the block level access list that are in fact mutually exclusive.
Right. So now we got more time to do this re-execution, and potentially we can make better use of multi-core machines to do that and do it a bit faster, right? I'm not going to say what the speed up is. I don't actually know. very optimistic and thinking maybe a 4-core machine can give you a 2x, but it might not be that. It might be a 1.5x.
Yeah, and we talk about it being faster, which really just means that we can do more in the same amount of time, because I think ultimately the goal still would be to raise the gas limits, which means that there are more transactions in each block. So you
Right.
can do more work in the same amount of time instead of doing the same amount of work faster.
So I'll mention here the gas limit increase that had been floated by Justin Drake last year, which was very aggressive. It was basically 3x every year. See that as a marketing ploy and not necessarily a hard engineering roadmap. Yeah. But with that, we would go to 300 million gas post Glamsterdam. Just to remind us all, at the beginning of 25, it was 30 million. Then 900 million gas in 27. That still seems quite doable with this structure on the current home staking nodes. If we have more time, we can use a course better. Then 2.7 gig in 2029. I think at that point we're really 28. Sorry, I missed my count there. At that point, we're really kind of pushing the current architecture, even with gas repricings, which will certainly happen as well to make that possible. And then past that, he was even thinking about 8.1 gig, 24.3 gig. To do that, we can no longer locally re-execute, which also would mean that local block building is gone. Now we have mandatory proofs. So that leads us into, and let's say with a huge heaping of salt, right? I'm not saying we're getting to 24 gig gas in Ethereum. I'm also not saying it's impossible. There is a roadmap there by 2030-ish. So zkEVM improving, what's that and how does it fit into all this roadmaps talk?
Yeah, I mean, I think this could be an entire episode, and it probably will be.
And it will be.
Yeah. But the main idea behind a zkEVM is that it's a zkVM, and the VM that you're running is the EVM. So a zkVM is basically a virtual machine. It's a model of a computer, and you can prove that you executed something successfully over certain inputs without actually having to reveal what it is that you've executed, essentially.
Yeah.
And that is interesting to us because it means that you can do a state transition on the execution layer and prove that it succeeded. And then you can publish that proof. And that process of proving is very difficult, and it requires specialized hardware, machines with lots of GPUs. It takes them a good number of seconds to generate the proof. It may involve gas repricings in the future just because certain things are harder to prove than other things. But once you have that proof, you can essentially just publish it alongside a block access list and say, I executed an execution payload and it changed these addresses in this way. So it has the before state and the after state. And somebody can take the proof and verify the proof, and verifying the proof is relatively easy. It happens in milliseconds, if I understand correctly, or on the sub-second timeline. And once you've verified the proof, you know that it is safe to apply the block access list, which basically is the state transitions. The block access list tells you what addresses in the EVM have changed in balance, and you can just add and subtract those balances or whatever the value changes are. And that means that as a staker, you're no longer re-executing every block that gets proposed, or at least it becomes optional. You can still do it if you want to, but since it's now optional, if we do raise the gas limit, we might raise it to the point where commodity hardware is no longer capable of keeping up by reprocessing every block, but is more than capable of keeping up by applying the proofs instead.
Right. And that's we'll get to where these talks are. That's the part of the roadmap, right? The linear Ethereum roadmap is to have optional ZK proofs to start. For a home validator, that might potentially mean you can run with 16 gig of RAM and a 1 terabyte drive, no problem, because you don't have an execution layer client anymore. And it may become rational to do this, meaning you still get your full rewards because you have enough time to do this through ePBS, as soon as after Glamsterdam. You know, there's other parts to that, which is, do we actually have clients that can do it? And are people publishing the proofs? So I don't expect this to happen immediately when Glamsterdam goes live, but it might actually become rational to do that still in 26 or in early 27 at some point. And I know that Justin has said his vision is that eventually the proofs become mandatory. And Guillaume, I hope I'm not misattributing, I might be, in DevConnect said, listen, local block building is dead. It just doesn't know it yet. Do you agree with that? Is that where we're going?
I think that it's a good direction for us to pursue. I can get into why I'm not super worried about local block building dying, and I think we mentioned it briefly earlier because of the FOCIL. But we're already in a place where double-digit percent, 90% of blocks are built by these centralized builders. So
Yeah.
for the most part, the only reason that the local block building is important still is due to that censorship resistance that we talked about before. And if we can fix that problem, then I'm not sure that there's a lot of value in saying that commodity hardware should be able to continue to build blocks.
I happen to be very pragmatic and agree, but I'm willing to bet that Mika would disagree.
Yeah, I think that there's something that's a little bit beautiful about the way that all the participants in the blockchain right now are roughly on equal footing, and that PBS is optional, and that you can be a full participant in the blockchain with just like a $800 setup. Although I haven't checked hardware prices recently.
Now it's more like 1600, but yep.
Yeah, everything's getting so expensive. But I think that if we want to have a really like a really competitive L1, which means you can do transactions for very cheap fees, like absurdly cheap fees. We need to find ways to raise the gas limit substantially. This is sort of ignoring the fact that L2s have solved this in a different way. And I think there are a lot of good reasons for the L1 to be as efficient as possible and to be as scaled as possible. And so I'm on the side of zkEVM being a good thing, and that we can sort of use other tactics to improve censorship resistance that don't require local block building.
Yeah, which does mean we want FOCIL and H star though, before that window closes, and we keep pushing it and pushing it and pushing it. It was proposed for Glamsterdam, then it was decided too much, not quite ready. Let's do it as a headliner in H star. Hegota, I think we're calling it now. So I really hope that happens. I think we need it. I don't want to see us get this centralized on the block building without having a way to force inclusion.
Yeah, I agree. And I think censorship resistance is sort of like core to the ethos of the Ethereum Alt1. There have been a lot of discussions that have come up in the past around, the US government and OFAC sanctioning certain addresses, and the idea that the Ethereum blockchain needs this credible neutrality, which means that we can't litigate who's allowed to participate as validators, who's allowed to send transactions and who isn't. That goes really, that like I feel that really strongly about crypto in general, is that it's unique because of its trustless nature and the fact that there is no central power that gets to dictate who's allowed to participate and how. So FOCIL is like a no-brainer for me. I think it's really important that we get it included.
Yeah, and to touch on that as well, right? So I view the block building part of Ethereum here as similar to an ISP. You had mentioned sanctions lists. I think those exist for good reason. When you look at who is on the sanctions list, we're talking, traffickers of humans, we're talking terrorists. These are not people that you want to enable. Um, and at the same time, when we look at how this works with IP addresses, which are also on the sanctions list, ISPs are not held to try and censor them in the network. They're meant to be censored where people interact with the internet, meaning on websites, on financial sites, that kind of stuff, right? This is similar. If you go to an exchange, that exchange might have a censor list and say, you can't work with us. But then once the transaction is in, it's just another transaction and the underlying network should be neutral.
Yeah, and I think that the goal of putting certain addresses on the sanction lists, I don't like to hypothesize or put words in other people's mouths, but I think it was basically to say that if you're an American citizen and you're sending money to these addresses that are controlled by terrorists or hostile nation states, that constitutes doing business with them, and that's illegal. I don't think the goal was necessarily to say that the infrastructure providers that make it possible to do business with them are also guilty of the same crime, right? So if that were true,
Exactly.
then any sort of infrastructure that supports a sanctioned entity would be culpable. So like the roads that they drive on, the ISPs that they use, to your point, would all be guilty of something that really was not something they participated in the first place.
Right. Do we have time to touch on two EIPs in Glamsterdam, or do you want to go to EthCC and wrap it up?
Let's touch on the EIPs. I can very briefly say I have not planned my trip to EthCC yet. I was supposed to do that today. I'm still supposed to do that
Okay,
today.
but you're going to be there.
I'm going to do my best to be there. Yeah.
Awesome. Okay, so 8045 slashed validators no longer selected to propose. So I'm going to put my Pikachu face on and say, the what? Why would a slashed validator ever propose?
Yeah, this is like an interesting sort of edge case that I think is kind of fun, and I thought it'd be fun to talk about. But the beacon chain's proposer selection logic doesn't take into account whether or not your validator is slashed. You stop performing attestation duties and you're forced to stay online, so to speak, and bleed out ETH over a certain amount of time. And if there's a correlated slashing, that number goes up. That's why your validator isn't immediately ejected from the network. Is because we don't really understand if more validators will be slashed after you, and that correlated penalty has to
Right.
be applied. During that window, though, you can still be selected to propose, which is counterintuitive, since you've sort of been ejected from the network, but now we're asking you to build a block. Um,
But then
and
if you do, we reject the block, right?
I'm actually not entirely sure if it gets rejected, honestly.
Okay.
um, but they'll no longer be selected to propose in Glamsterdam. So that's like a nice small change to the selection logic there. That kind of
Yeah.
removes something that would violate what's called the principle of least astonishment, which is like one of the guiding principles in system design, which is that a good system doesn't astonish people more than it needs to.
Okay. Yes. And I certainly, when I first heard that, I felt astonished. It's like, how? What?
Yeah, and
Okay.
there's another similar subject with sync committee participation where you can actually exit your validator and you'll stop receiving a tester duties, but then suddenly you're in a sync committee, and that's
You get
because
sent committee duties. Yep. Okay. So EIP 8080, I'm assuming that's disallow using the consolidation queue for exits.
no, it's actually to
So maybe
let exits
explain
use
what's
the
going on now
consolidation
and
queue.
what do they want to fix?
Yeah, so there's this weird edge case that I think everybody missed and until somebody started exploiting it. But basically, when we added 0x02 validators, I believe back in Pectra, MaxEB went up. Is that right? Is that Pectra? That feels right.
Yep, that sounds right.
We added a new queue, which is the consolidation queue. So basically, you could take a 32 ETH validator, convert it to a 0x02 balance, and then consolidate a bunch of 0x01 or 0x02 validators into it, where the balance of each of those subsequent validators is transferred to the first one. And you can take a 32 ETH validator and increase its balance all the way up to 2048 ETH if you want to.
So say I've done that, and now I have 2048 ETH in my validator, and I keep consolidating another 32, another 32, another 32. Now what happens?
Yeah, so nothing unpredictable. Those balances just get added to your 2048 ETH validator. It's allowed to go above the max effective balance. The keyword is effective. It's not a maximum balance. You can have a balance higher than the max effective balance. In fact, most validators in the network have a balance above the max effective balance because they're earning
Which
rewards.
then gets swept every
and then it gets
10
swept.
days. So.
Yeah. So in a scenario like we actually had shortly after Pectra, a lot of exits were happening. I think that was the Kiln incident, or I don't really remember, but there was a huge rush to the exit queue.
Yep.
And it could take weeks to get your ETH out of the beacon chain. It was actually faster for a while if you had a 2048 ETH validator that you weren't trying to exit, but you wanted to exit a different one. You could just consolidate the other validator into your 2048 ETH validator. And then when that validator got swept, the full balance would basically be swept. So if you take 2048 ETH and you add another 2048 ETH, you've got 4196 ETH balance, and that's way above the max effective balance. So when it's your turn to be swept, 2048 ETH will be taken out of it and sent to your withdrawal address, which means that you could essentially front run the exit queue. So EIP 8080 is designed to close that loophole.
It closes that loophole, right? So I remember looking at the exit queue and thinking, well, we have 256 ETH and epoch, but we got these other 256 over here for consolidations. We could use that. And bringing that up to Lido, I thought this was as designed, and then being told, stop talking about that.
Yeah.
Which was my first hint that this wasn't as designed.
I think that it was originally discovered because somebody did it. Somebody figured it out and they used it. And then I forget if this is exactly right, so don't quote me on this. I know this is being recorded, but the Petrified website developer observed that somebody had done it, and they asked the core devs, like, hey, did I get something wrong here? And they're like, that's not supposed to happen.
Right. We just didn't think about that corner case. So now 8080, which is, to be clear, still considered for inclusion, not scheduled for inclusion, right? It would close that loophole, and you couldn't do that anymore. I'm assuming
it closes it in a very elegant way.
Consolidate.
Yeah, the way that it closes it, and I haven't read the text of the EIP, but basically when you are exiting, you can exit through either the traditional exit queue or the consolidation queue, so they should stay roughly equal in size. It basically democratizes access to this feature so that you don't need a 2048 ETH balance validator anymore to use the shorter queue. You can do it no matter what.
At one point, Ethereum said we're going to have a hard fork every 6 months. It was kind of clear to people that that's very aggressive and optimistic. We're certainly not going to see Glamsterdam in June. I don't see how, because we still have 20 EIPs that are CFI'd and not even scheduled for inclusion yet, these among them. So we don't know what even goes into Glamsterdam yet, and we have 3 months left. So best guess, when are we seeing Glamsterdam?
This is really just like a finger in the wind type guess, but I'm going to say September, October, somewhere around
Interesting.
there.
Yeah. I'm on September myself. I think that's my finger in the wind is September. Okay, EthCC. So we're gonna have the EthStaker stage on April the 1st as part of EthCC, and we're gonna have some talks there that go deeper into some of what we mentioned today. There's going to be a talk on ePBS, what EthStakers need to know. There's going to be a talk on FOCIL, past, present, and future. I'm going to briefly talk about a niche topic, which is home staking behind CGNAT. So if you're in Latin America, Asia Pacific, or in Europe behind a CGNAT, carrier grade NAT, and you can't get peers, this might be interesting. Then in the afternoon, we're talking issuance. That's going to be spicy. Justin Drake is going to give us a staking straw map, similar to what he did for Ethereum total. So that'll be, I think, very interesting to see how he sees the staking game evolving. Then there's going to be a scaling roadmap by Marius van der Widden, Geth, another ePBS talk from Sigma Prime, and then Rocket Pool talk, and we are going to wrap it up. So we're going to have a full day of talks that are relevant to stakers.
And where can I go to find out more?
Where can you go to find out more? Exactly. I'm going to leave that to Hanny to put the link in because I don't have the link ready, but it'll be in the description. Make sure it is Hanny. Thank you. And yeah, with that, thank you, Patches, for this talk. It was really awesome. I learned a lot.
Super happy to be here, and I will hopefully see you in Cannes if I can get my flights sorted out.
Exactly. So those of you who will be at the staking talk, just say hi. We always like to shake hands. And then otherwise, I'm sure we'll have another one after Cannes discussing all the things we learned there. Maybe another brief thing on do we now fully both understand the slot timeline in ePBS?
Oh, yeah. We'll follow up
That's
on
mostly me not understanding it right now. And then what is FOCIL doing and what did we learn from the staking straw map? You know, what's coming down the pike. All right. Thank you. Until next time.
See you later. Bye.